well, today's event we start a little bit early, so I hope everyone having talked to each other a little bit. But don't worry, we will have another section after the event. We can we'll go to a bar and at around 8 o'clock after our event, and we can continue talking to you guys. So, Robbie.
So before we get started, we're just gonna ask you to take out your phones, because right, everyone saw this on the MM trailer on the movie theater. Right. So take out your phones because we want you to give us some inputs on our surveys for our future events. So if you go to moralideas.org/twdatany, and you will see like a bunch of So you'll see this. So basically, we're asking you to see which kind of event, like of the pair, interests you more, and then you can cast your vote. And if you cannot decide, you're like, oh, they're all the same. You can put it here, and then input Y, or you can also add in your new ideas. So it kind of cycles through the same problem after like 5 times. And yeah, so. So hopefully, this is the current data. So hopefully we can beat what we had 2 months ago. And so I'll let you do it. Go here. And these are, so see the results will change after that. Alright, so we'll also talk about our code of conduct. So you should not face any type of harassment, microaggression, fake surprises, regardless of your gender, sexual orientation, expression, and disability and physical appearance, body size, race, and religion. If you do encounter that, please let one of the organizers know. So if you're an organizer, raise your hand. So yeah, so feel free to approach us and talk to us. And be kind to others. You should not put down other people's thoughts, and just, you know, be kind, not just be fun. All right. So hopefully you all input some of your ideas, and let's see if our results. Yay! So we have double our unique user sessions just within the last 3 minutes. So, we also are looking for more volunteers. So, Taiwanese Data Professionals was founded in February as a meetup, and we are here to highlight the talents among Taiwanese American Taiwanese with odds in the broader data-related fields, so including data analysts, data journalists, data engineers. And if you're interested in helping out in our event coordination or nominating speakers, or managing our blog and social media, let one of the organizers know. It will be really great for us to have your help. And we also have the next meetup determined. It's in 4 weeks. So we usually have monthly events at the end of the month. On Friday, we'll have one Taiwanese Nancy Chan from IBM to talk about job searching. And we'll also have Catherine Brian from National Grid. She's going to talk about hypothesis test. So that's the rats there. Cool. So yeah, we're kind of running a little bit late. So we'll have Annette and Paul to give us about 20 minutes talk. After Annette's talk, you will have like 5 minutes to ask her a question, and then we'll let Paul talk, and then we can do more Q&A for both of them. After that, I think we can stay here a little bit past 8. We can stay here until 8:30ish, and then if you also want to networking, we can head to a local bar. Cool. All right, so that's all. That's all right. Here you go.
Hello everyone, my name is Annette, and today I'm going to talk about how to apply ChangeFashion with data science. And today I will using free method to introducing how to using data science to improve sales and how to using to do market research. So I'm talking about what's the fashion industry background, and the first is how to doing category dimension, which is how to using optimization to do pricing. And the second is the competitive positions, and which is how to using Python to do market research. And then finally, I will demo some Tableau or BI tools to understand what is the customer need. And so here's our products. I'm working in a company. We are producing yoga leggings and yoga activewear. And then we currently marketing in United States. And we have a designer in the British. So I have a little bit talk about what's the background of the fashion industry. So first is we have a design team in United Kingdom and US, which is doing some research of the marketing trends, what's the color for the next season, what's the customer like. And we also have a manufacturer which have experience in producing many clothes. And then we have a marketing team in New York, and we're doing market research, PR, and accounting. So currently we are running three kinds of business. So first is B2C, which is have higher markup and more revenue. And the second is B2B, which is the reselling our clothes to Macy, JCPenney, different types of platforms. And we are the supplier of the DK New York, Calvin Klein, Gap, and some polo clothes. So those are the three different types that we earning different types of markup. And the blue one is even though we can have higher profits to do B2C, but we also have to using many budgets to do marketing. So this is how we running our business in New York. So the first is how to do the pricing analyst. And there are different kinds of methods, and this one is more theoretically, but I think it's really useful to do the market research and how to pricing. So first is we have an initial inventory for 150 packs of leggings, and the total cost and for example, each of the leggings will be $1. And then the assumption is demand of our leggings will changing depends on the time, and each of the time will have a different pricing and different demand. So the optimizing is we have to find out goals, what we're going to optimizing. So the target is the price and multiply the demand. We're going to be our revenue. So our goal is going to higher the revenue. But we also have some limitations. So limitation is we don't have much inventory. And the inventory, and the second limitation is the demand have to be positive. So those are two limitations, and one is maximization to be optimization. So if you having some market research, so the assumption is we already know the curve of the market we're going to. And so we define some factor A will going to be 200, B will be 10, D will be 10. So using this Python, we are going to predict, or we are going to know how the market can go and how the pricing can go. And then in this case, we are using some basic Python package like NumPy or pandas. So those are the basic package we're using to run in Python. So in this case, we can see like different time will have different colors. So for the first hour, the line can be like the red one, and the second hour the line can be the blue one, and the horizontal is the price, and the other side is the demand. So we can see when the price going up, the demand will going down. So that makes sense, like different time, different price, how they run in the market. And when you're using some package like Singborn, which is the Python package, and they can help you to build up the map. And they are also telling you what kind of price the demand of the market we're going to have. So you can see like selling at 55%, and the time is like I said 6 months. So the demand going to be 11. So we can use this heat map to predict the market and also using to pricing. So, but actually, those kind of scientific things is really hard to apply in the real market, but we have some fundamental to know the market based on these things. So this is our product line is each season. So each season, our designer will design their clothes, like they have leggings, they will have different kinds of pants, different kinds of clothing. And our goal is like how to find out the best way to pricing out products and making to the United States market. So our category we're going to have our cost of each product and logistics. And we also have in mind that we have different kinds of market for each of the products. So when the buyer or when we sell into the market, we can detect that what's the profit of each of the product and how much can we earn in this product. So you see the first one is not a good case because the margin is too low, so we probably cannot earn much money in this product. But the second one, you see, we have between 30 and 40 markup. So which one is really nice for us to predict in the futures, and it's really good for our product lines. And we also have the retail price, and also have a monthly sales to predict. So using those kind of knowledge, we can analyze it. So this is our website, and we actually trying different kinds of price in our product lines. And then our products, sometimes we will have a discount to a wholesaler, and then we using to put in the record of the price. So different kinds of company will have different kind of discounts. So how to set a retail price, which is really hard to find. So we also were using some technical skill, or also we are talking with designers and what they want going to pricing their things. One of the methods is not the only way to do a retail pricing, but some people or some bigger companies will using Python to track or do test mining from different types of websites. So in this way, they have a more efficient way to collecting data, and they can also have a real-time dashboard to see different types of price in different types of platforms. So in this case, will see different kinds of title of the products. And the second one is a different kind of price of each product. And also have URL, and if you go into more detail, it will have different kinds of pattern, different kinds of texture of each product. So sometimes we are collecting those kinds of data to Excel sheet or also using database. And then we'll find out like what kind of price we are going to target. So for A and B, that's probably too high for us. And then for G and H, probably too low for us. So we are focused on C, D, E, F, and we will also see what kind of words they are using to naming their products. So the following is our product, and the above is the Lululemon. So we are different kinds of strategy when we go into a market. And when we're doing pricing, we also have to understand the customer need. So we also were tracking how people reacting to our platforms. We are using Facebook and all different kinds of social media. We are using Google Analyst to checking those kinds of things. And we also do some surveys to understand our customer. So this is one kind of case that how we see how people interact with our platforms. So this happened in the Instagram, that average how many likes and how many average engagement and the total participants in each one. And those can transfer to a market value. And we also do much to want to understand the market and what is our customer need. So we'll do some surveys. And then I usually using Tableau to analysis. And also using Python can have some segments. So here's our client name, and those are different types of clusters. So if we using a customer cluster, we can see different kinds of quantity. So which means that we can have different kinds of campaign to different kinds of customers. And we also can use Tableau to see how clients thinking about our products. So first one is that they just don't like the style of our products. And the second reason might be they think the size or the style is not like unique, and probably the large one, the large size will be too small, or the small size will be too large. So this will happen to our fitting problem. So when we're doing the fitting, we're asking the model to the office, and then we'll do several fitting to them to see the clothes is nice or not, and then we will send it to the sample to the factory to do the productions. So when we do the surveys, we can also understand what the customer needs and the fitting needs. So in this case, we can know that for the Excel font size, they provide the style of the design, and some people might think the leggings were too long. So this is how we see the inside of the data. And finally, we were also using Tableau to see how sales, and then we have weekly meeting to see how can we improve the market. So thank you for listening to my talk.
So I think we have like 5 minutes for a short Q&A. So if you have a question, you could listen. Yeah.
Do you have any recommendations for the research for data scratching?
Data structure.
Yeah.
I feel like some people using beautiful soup, which include text mining, and when you're doing the naming of the each product, and you can using beautiful suit to see what kind of keyword you want to name in the product. And for Taiwan, they have some modules you can change the price. So when you're looking at different type of CSS structure, then you can catch it from different platforms. And it's interesting that different type of platform are using different type of structures. So it will take time to have to test money to each of kind of
What about those online tutorial, like articles to show you how to start from scratch? Like any...
I mean, you're asking for the tutorial for Scrappy,
yeah,
or
like how
just...
to develop.
So how do you learn web scraping?
web scraping. They have different types of tutorials from YouTube or also from textbook. So we can talk about more about how to do data mining or web scraping.
Any other questions? Yes.
With the, as you collect your data on each of the styles, but the styles only stay in season for a short amount of time, do you see that the same trends carry over between seasons? Do you see the same insights and trends carry over between seasons? Because each style is only in season for a few months at a time, right?
Each of the season will have like 20% is for fashion style, and mostly we are using basic style, which means we will not lose the market, but we can still try 20% for more exciting things or more new innovation. Yeah.
May I have a question after that? I mean, you show the price model at the beginning, right? I mean, how do you model the different styles in here? Because you say that you have the basic model, and you have the basic style, and you also have the on-season style. And those two styles have a different decays curve for their price.
Initially, we'll have different price setting because of a different texture. Because some texture we're using more polymer, so they will have a higher price for the items. So we have to working with the designer, because the designer know more about how the cost is this item and what the style we want to buy.
Have questions? We can take one more questions. If not, I will take it in the on this.
I have a question. Why is JR so good for selling everything? If you go back one slide, like you had a breakdown of who sells it. JR sells like 10 times as much as everyone else.
I think that guy is really aggressive to sell. So it's not issue about the sales. And we are in the star status. So hopefully after hiring more more sales, we will have different titles.
So you don't have to take aggressiveness into account with the models?
That is a good question.
Okay. Yeah, we will have another. Oh yeah.
I have a question. So, do you ever take into account like the effect of luxury goods? You know, where if you increase the price, the demand might increase as well. So how do you model those steps?
Can you repeat the question?
Yeah. So, do you take into account the effect of luxury goods, like in fashion, certain types of brands, certain trends? You know, the more expensive they are, there's somehow a surge in demand. So, how do you optimize revenue when you have this inverse demand curve?
That's a good question, and I think you have to do a segment at the beginning to see what kind of target market you want to do. So when we doing the research in the yoga activewear, we will see that Lululemon is like as a luxury brand for the activewear. So we are doing the medium place to do targeting.
So yeah, thanks Annette, and
So, I don't know, I really like that first talk because I'm super into pricing and stuff, so I feel like this is going to be a hard act to follow. But luckily I've got a pretty good topic. It's a dry technical talk on date times, so I think it's going to go over well. All right, so
Can you speak a little bit louder?
Sure, yeah. So obviously this is a data meetup, and I'm talking about something just generic like date times. Oh, actually, sorry, let me tell you who I am first. I'm Ganssle, I work at Bloomberg. I also maintain this library, python-dateutil. It's a very popular library for manipulating date times in Python. Pretty much most of the things I talk about are going to be very Python specific, but there are probably analogs in other languages. So, right, this is the data meetup, so why do you care? If you look at Pandas, which is a data science library in Python, they've got 12,500 issues in their issue tracker. If you filter that by ones that have to do with date times, there's 2,980, which is about a quarter of them. So this is pretty important for a variety of reasons when you're working with data. But why are there so many problems? So first, if you're looking at time zones, maybe you think time zones are kind of easy. But what if you have to deal with something relatively simple like non-integer offsets? You know, some things are like a half an hour off, or 45 minutes off, or even, before 1979, a non-integer number of minutes off. There's also places where daylight saving time transitions happen more than once a year. So Morocco, since 2012, you have regular daylight saving time starts right around April, as you would expect. And then, weirdly, for like a month in the summer, it just goes away, and then it comes back. So what happens there? So Morocco is a Muslim country, and this month is Ramadan, and Muslims, they can't eat until sundown, so they want that to come as quickly as possible, so they just turn off daylight saving time. There's also some people who say, okay, well at least if there's one bedrock, there's exactly one time zone per place, right? So in China, they have one big time zone, right? And I guess that's probably not super great for the people in the far west. In fact, it's so not great for the people in the far west that some of them have kind of broken away, and there's actually two time zones in Xinjiang. There's the UTC +6, which are used on, like, I guess, according to Wikipedia, the breakdown is if you're a Uyghur, then you use UTC +6, and if you're Han, you use UTC +8. So it's just a racial time zone. So that's time zones. Everyone loves those. There's also parsing. So if you want to represent date time as a string, you might represent it in any of these ways, right? Dealing with that. That's just the ones that are compliant with ISO 8601. So that's just standards compliance. That doesn't include things like this that regular humans do, like 2014 February, or this is pretty popular in China and Japan, where you have this year, month, day, just a time, some shortened thing, 13 November, this December, dot, a bunch of numbers. All these things, these are things that you could really get in a real data set. There's also recurrences. So say you want to know when the market closes in New York, but you're trying to work in UTC, so you want to know, you're going to say, okay, well, UTC UTC -5, that's 10 o'clock is about 5, right? But then daylight saving time hits, you can't necessarily do that, right? So you're going to want to express a rule that says, okay, market closes are Monday through Friday at 5 o'clock in the local time zone, and then you're going to have to transform that. So that's another thing that you have to worry about, is recurrences. But also calendar offsets. So if I say something is 1 month from now, what does that really mean, right? Well, what's 1 month from January 31st? It's not February 31st, right? So is it February 28th? Is it 30 days after? Is it, what is it, right? So really you need something that has kind of fixed semantics, or at least something where you can understand the semantics. In dateutil, I'm not really going to talk about this relative delta, but we do provide something like that where it includes these sort of more fuzzy categories like months and days, and you can also do things, you can express, okay, the end of the month, right? You start at the end of the month and then you go forward 1 month, or the beginning of the month, which is to say go forward 1 month and then set the date at 1. Okay, so now that I think I've convinced you that datetimes are complicated, I'm going to tell you about this library that I work on that solves a lot of these problems, or at least makes it a lot easier. An overview of the packages in the library, the modules, the submodules. We have TZ for time zone handling. We have the parser for parsing arbitrary datetimes. We have RRule for handling those recurrences I mentioned. Relative delta does the calendar offsets. And another one I'm not going to talk about is Easter, but I can explain exactly what it does right now. It tells you when Easter is, which is a surprisingly complicated question, but it's pretty easy to understand how to use the API of that. So, okay, so getting right into the meat of things, this is TZ. Now, I'm telling you that most of that first set of slides is all about time zones, right? Because time zones are very complicated. This is a sort of broader talk, but I have a time zone specific talk that's 40 minutes long. You can go on my website. It goes into this in much more detail. But I'm just going to give you the bare minimum of what you need if you're going to use dateutil's time zones, which is what's recommended by the CPython documentation. They do not recommend pytz anymore. So dateutil provides a UTC object. This is pretty simple. This just represents UTC, which is the base unit for all time. It gives you have either just the UTC object, or you can call this UTC function, which is basically there for legacy reasons. There's also TZ local. So if you want a time zone object that represents the current machine local time, there's all you need in Python to handle that. It is available in the standard library, but there's no TZ info object that actually does it. So dateutil will provide one of those. And as you can see, I've got some examples here where I take my date time and I turn it into local time. My local machine is Eastern Daylight Time because it's the summer. If my local machine said UTC, it would give me UTC. And if I give it a daytime that's 6 months from now, it'll give me something that's in standard time. So TZ local is aware of daylight saving time to the extent that your machine is correct about that. There's also TZ file. So you shouldn't actually call TZ file. I've just called this TZ file because that's the class that the function gives you back, but you shouldn't actually construct it. So what TZ file gives you is the INA ships out this database, the time zone database. It's a mapping of these keys that are sort of continent/city names, and each of those maps to a database which is shipped with most computers, except for Windows, because Windows is weird. And it has all the historical time zone information. So whatever time, you give it a time and you run these, and it'll tell you what time it was, or what the offset was. So for example, we take the New York one. I take something that was like some date in 2016, and I get Eastern Daylight Time, sure. I give it a date in 1944, and I get this EWT, right? That was Eastern Wartime. So during the war, for rationing reasons, they just turned daylight saving time on all year round. So even in January, it was daylight saving time, but that was called Eastern Wartime. If you go all the way back to the beginning of the century, you get LMT, which is local mean time, which is before the standardization of time zones, and it gives you this weird number that's like minus 4.93. So those are pretty much the gold standard of representing your daytimes as in time zones, or your time zones in, correct. So I said you're not supposed to instantiate these TZ files directly from a file. What you really should be doing is using dateutil's getTZ function. So the getTZ function sort of acts like the same as if you set your TZ variable in your computer, except that it does it with, except that it gives you back a compliant TZ info object. So if you pass it nothing, it gives you something representing the local time. If you pass it one of these IANA zones, like this Christmas Island one, it'll figure out where on your disk to read that information and give it to you back. If you give it one of these TZ variables, this is some string representation, semi-standard string representation of Australian Eastern time. So it'll work for that as well. So basically use this getTZ. getTZ will always return the same time zone object for the same input string. This is important. It's partially important for performance reasons, but I'm not really going to go into how this works. But this is just a little teaser of something that I go into in this blog post and also in the 45-minute version of this talk, where if you take this specific date time, you turn it to a timestamp, and you turn it back, and in one case, you use the same time zone info object, and in the other case, you use this no cache option to get a brand new instance. You can see that x equals y is false, so this and its round trip are not the same object, but x is the same object, weirdly, as the round trip with a fresh time zone object, and strangely enough, y and z also equal the same date time. So you can find out why this has non-transitive equality behavior on that post and in that other talk. All right, so moving on to the parser. The parser doesn't take too much explaining. Basically, it's mostly automagical, so you pass it anything that is a valid date time, like a string representing a valid date time, it'll give you a date time on it. So you can spell it out in words, you can spell it out like this, you can give it ambiguous date times, well, things that could be ambiguous date times, and it'll figure out, okay, well, this one, the 11 can't be a, well, actually it can. I guess here, it's like 32 can't be a day, right? So it makes sure that that's a year. So things like that. So when you want to use the parser, you want to use it when you don't know the format of the string. You want to use it when there's like some string that has other things in it, but also has a date time in it. You want to pull that out. You can also use it to pull out time zone information. So these guys are close enough that you can actually get some time zone offset from it, and so these will actually give you time zone aware date times from the string. There's also things like CST, which could mean Central Standard Time. It could also mean Cuba Standard Time or China Standard Time. So the parser gives you this ability to have some mappings, and then it will actually do the mappings for you. I'm also very proud of this one. I just added this in the latest version. This is ISO parse. So ISO parse only parses ISO 8601 standards compliant date times. So if you know that it's supposed to be an ISO 8601 date time, such as the date times that come out of datetime.iso format, you should use ISO parse. And why would you use it? It's faster. It's a lot faster. The first one takes almost 200 microseconds. The second one takes 26. It's also stricter. So this is not a standards compliant date time. If you pass it to the parser, it'll give you the right thing, but it won't let you enforce that all the date times that hit you are ISO 8601 compliant. But if you pass it to ISO parse, it'll give you an error. So when should you not use the parser? You shouldn't use it if you know the format. You can just use strp time. It will, again, be faster, and it'll also validate it. Don't use it to validate whether something is a date time. If you just put like a string with a number in it, it'll be like, oh, that's probably minutes, and then assign it like today plus that many minutes. But that's what you get for having an automagical thing. And also, if you know that it's one of 3 formats, just guess and check them, because again, it's pretty slow. All right, so I think this is the last one I'm going to go into. This is the recurrence rules. So dateutil.r rule provides these recurrence rules. Recurrence rules it's an RFC standard that, IETF standard, on how to represent recurring events. And recurring events are very complicated. So, for example, Pat Morita is an actor. He was in The Karate Kid. His birthday is June 28th. So what I've done here is I've written a rule that only generates date times between his birth and death, and only on a Monday. And then what I did was I said, okay, if I want to know how many times Pat Morita's birthday fell on a Monday during the Vietnam War, I can use this rule.between. I find out that it was in 1965 and 1971. So obviously that's probably enough, right? Like you guys all are like, well, now that I know the Pat Morita thing, that's enough. Like that's all I was going to use it for. But there's other things, shockingly, that you can use it for. So I'm going to go into a little detail about exactly how it works. So the fundamental components of an R rule are the DT start, which is kind of like the phase of it. It's when the rule starts. The frequency, which is the units of the fundamental frequency. So if you just take something that starts on a given day and then you pass it daily, then it'll give you that DT start plus 1 day, plus 2 days, so on and so forth. And then interval is the number of the fundamental frequency that is each recurrence. So it's easier to explain with an example. So I created an hourly rule. So its fundamental frequency is hourly. It starts on this day at 9 a.m. And the interval is 1. So you can see it goes 9, 10, 11 for the first group. If I then replace the DT start with something that starts at 10 and regenerate it, I get 10, 11, 12. And then if I change the interval to 2, instead of going 9, 10, 11, it goes 9, 11, 13. So pretty simple. Here's where it gets complicated. So there's the by rules. So essentially, by rules allow you to increase or decrease the frequency of these recurrences. So, and the way it works is, if the frequency of a by rule is higher than the fundamental frequency, then it tends to restrict the frequency. So, for example, this is a daily rule. So this should be generating all the days starting on this DT start. I restricted it by weekday, so it's now only going to give me Tuesdays. And then I've also restricted it by month and done it in November. So instead of it starting in January, it skips over everything that's not restricted to the by month of November, and it gives me all the Tuesdays in November. If the rule is less frequent than the frequency, then it increases it. So I have a monthly rule. I add 3 bi-month days, the 1st, 15th, and 30th, and you can see it gives me the 30th, the 1st, the 15th. There's no 30th. It skips over. It goes to the 1st and the next. And then normally, if you sort of just start with this, like if you just pass it all these arguments and you just try and convert it to a list, it'll generate all the date times from DT start until Python can't represent the date times anymore, which is in the year 10,000. So you're going to want to be able to limit it. So the two main ways to limit it in the rule itself are with count. So if you give a count of 2, it'll give you exactly 2 instances of it. Or with until. So you say, all right, I want all the instances of this rule until 2018. So you do that. So those are pretty self-explanatory. So here's an example of, and then once you have them, even whether you've limited them or not, there's a couple ways to retrieve specific subsets. So you can use our rule after, that gives you the first instance after, before, the last instance before the date you specified, or between. Here I've got all the Easters between 1995 and 2000, even though the full rule gives me all the Easters from 1990 to the end of time. By the way, Easter is something that we added in this module. I don't know why the original guy who wrote dateutil is so obsessed with Easter, but like this is a non-standards compliant thing because of Easter. So where you're going to encounter these a lot is in the strings. The original spec refers to a string. So our rule string is a function or a class or whatever that generates these from the strings that you might get from, say, Google Calendar API or some other standards compliant API. If you want to emit these to other languages or to APIs, you can just call the string function on your R rule, and it'll give you something standards compliant, except for if you have this by Easter in there, because again, but it still represents it. I guess we'll try and start the trend of including Easter in this for some reason. All right, so some of these rules can't be expressed by a single R rule, which is what the R rule set is for. So R rule set, you can add an R rule with .R rule. You can exclude it with X rule. You can add a date with R date, and you can exclude it with X date. So, for example, if I want to generate a bus schedule, right? So I'm going to start with a blank R rule set. Weekdays, this is the weekdays and the weekends. So if I start with it, first I create this rule that says, all right, every day during the week, on the hour, like during the weekdays, on the every hour on the 37, from 6 to 10, I want an occurrence of this, which is when the bus is coming. But after 6, it only comes every other hour, right? So I have to exclude 7:37 and 9:37. So I create the exact same rule, but instead of going 6 to 12, I do just these 19 and 21, and then I X rule that, so those will cancel out. Then what I'm going to do is, on the weekend, I have the weekend specific rule. I can add a new R rule from 8 to 7, it goes on the 7th, I add that. So on November 8th, 2016, we'll say, which maybe say is election day, so politicians have arranged for buses to undergo service because they maybe don't want people to get to the polls. So what you can do is, you can say generate all the date times from the original rule and make them one-off exceptions with X date. But they're not heartless. They've added 2 buses, for people who need to get to work. One at 4:32 a.m. and one at 7:49 p.m. So they do that with an R date. And then with some magic that you can see on the repo for this talk, I can convert all this to a pandas data frame and just print it out. And you can see I have the normal rule on the 37 for Monday. Tuesday, the politicians have messed with the schedule, so you only have these 2. The rest of the week is normal. And then on Sunday, you have this slightly different thing, which is on the 7th. So that's how you generate a bus schedule with an R rule set. All right, so that's my talk. You can find more on GitHub for dateutil. I'm always looking for more contributors, so you go to if you go to the issues and click on the Help Wanted label, plenty of issues that you can look at, and I'm always looking to improve the documentation as well. So even if you just read the documentation and try and use the module, and then you're like, oh, this is horrible and frustrating, you can just send me an email or open an issue that says, oh, this is horrible and frustrating in these very specific ways. That would be very useful to me. All right, so let's go talk.
Let's have Annette on the front and feel free to ask questions to polls or to anything. Yeah. So, yeah, raise your hand if you have questions. And please speak as loud as you can because. Yeah.
Actually, for the python-dateutil, what are some usual use cases for this language?
I think probably the parser is like the big use case because it's like people like to specify things as strings. So a lot of people use the parser. The parser is like kind of complicated. I've been really pushing the time zone stuff and like keeping it improved. I have a whole blog post about how Py2Z is like probably not the right thing to use because of some very important and like smart engineering choices they made before those engineering choices were eventually like turned into the wrong thing by the daytime API. But yeah, I mean those 2. But also the recurrences. Like our rules are actually pretty much everywhere. They're pretty commonly used in scheduling emails, scheduling meetings, that kind of thing.
So it's like they could be fed into some scheduler.
Yeah. I mean, you may have even seen some of these like implementation details sort of leaking out, where you can schedule a meeting, Tuesdays and Thursdays, or like on certain days of the month. You'll sort of recognize the signs that someone's using our rule somewhere.
Any other questions? Well, I have a question for you. Actually, this is my 3rd time to listen to a talk.
Can you speak louder?
Okay. Sorry. So yeah, it's actually my 3rd time to listen to this talk, and I never asked you this question. What motivated you to start this project and become you're the main contributors for the project, right?
Yeah.
Is this your is this project you initiate, or someone else that you initiate and you just take these over?
Yeah. So this was originally written by someone like maybe 14 or 15 years ago, not me. And when I sort of wanted to become a software engineer, I started doing some contributions to open source, and so I started using Matplotlib, or I had used Matplotlib a lot, and I was like, I'm going to contribute to Matplotlib because I used it a lot. And then they said, oh, like try and find something with documentation or whatever, and I was like, okay, fine. And I searched the issues. I found some documentation issue that was actually a datetime bug, and the datetime bug was actually in dateutil. So then I fixed that bug, and then there was like a couple other issues in the same module. It was in our rule, and then so I fixed that one, and then the next one And then like there was a couple others, and people were asking questions, and I was like, well, now I know about this, so I'll answer a couple questions. And then like 2 months later, I was the main maintainer of it because I was maintainer number 4, and the other guy was having a kid, and it was the whole thing. And, yeah, so I guess it's just a weird rabbit hole that now I give talks on date times.
It might be a fake question, so it's totally fine if you say you want me to refer to some blog post or any article that you already made. But my question is when we do with the big data project, it's highly possible that, let's say the data sets for 3 or 6 different years, so within the same organization, they probably switch the data format. Maybe not just once, maybe twice, or you countless times. And if you just simply use SQL, trying to see, let's say, how many records for each year, that you will find you probably just come out with 2 years, then others are all, it's not showing up the year just because of the time issue. So what will be your first step to checking, to figure out how many different times daytime format that we use, or what would be your first step to trying to figure out the way in the darkness?
Yeah, so one possibility, so I think that is a really tough question in terms of like how you would approach it. One thing I'll mention is that I mentioned that the parser is pretty slow. Pandas has a lot of optimizations where, so Pandas will fall back to dateutil's parser if it really can't find like a format for it. But Pandas, it has a much faster, and it's kind of it's probably cached, and it's also Pythonized way of inferring datetime formats. So they're actually pretty good with that. With dateutil parser, one of the things that I've really wanted to do, but I haven't sort of been able to wrap my head around it, is not only like emitting the datetime, but also emitting the format that the datetime is in. So I guess the answer would be like wait a year, and then you can use dateutil to go through. Another possibility is, see if maybe Pandas has something like that. I don't know that many ways to like figure out what the format was. Most people don't admit that because most people don't care. You could also just throw everything at the dateutil parser, assume you got the answer right, and maybe look for discontinuities in your data. But once you have it out, then you just put it back in the ISO 8601 format. Like your best bet is probably to normalize everything, but obviously that's a lossy process. Especially if you switch from one ambiguous date format to another. And like you can even have problems where, for example, say you used a format that was like just 3 digits, right? It's like 01, 01, 01, right? That one's fine. 01, 01, 02, okay, that you can sort of parse it. You can guess which one it is. Like it's probably year, month, month, day, day. And then you get to something where you get year, like 01, 3201, and now all of a sudden your year, month, day, day is wrong. You go back and fix the first 10, or is this the first one that's in a weird, like some of these things that you can get to an unambiguous example, and dateutil doesn't right now go, there's no facility for sort of going back and saying, oh, here's here's a whole series, they're all in the same format, figure it out. Or they're all in one of a couple formats, but it's something that I really want to do, is like start emitting the format, and because that also lets me cache in the sense of like if you give me 100 of these, or 1,000, or 10,000, or 100,000, probably they're in, even if they're in a bunch of random formats, it's probably in one of 20, right? And then if I've already done the work, if I only have to do the work 20 times out of 100,000, that's way better, right, than do it every single time.
I have a question for it. So we know like right now doing data science we need a lot of technical skill. Oh, sorry. So doing data science right now we need a lot of technical skill, but what is like things like aside for technical skill, like something like domain knowledge, like this kind of stuff, and statistical model, like you think it is equivalent important as the same as technical skill, or like what is your experience at work and the different from where you learn the skill?
When I was in my undergraduate, I was studying industrial engineering, and the education let me know that much about optimization and how to do operation research, which can use in booking tickets, and how to do some basic mathematics and python or some technical skills. And getting into like a user experience, user interface, which let me know more about design. And I was having an intern in National University of Singapore, and I was doing some digital testing, which is how to collecting human testing to a data. So my experience helped me to know more about how to coordinate with people, and also know how to translate non-data things to data. So that's my background to get into different kinds of industry. So I'm not a fashion kind of people, but I can use data to analyze different kinds of market. Yeah.
So do fashion people like very care about data visualization, or they really care about it? You're all saying like it's the fancy graph chart is more important than this.
No, you have to taking time to argue with the designer or argue with the sales. So when you analyze like a fitting is not good for the customer, but the designer will argue with you that our fitting is quite nice. It's because of packing issues. So you have to have a meeting with others. Yeah.
Have you ever met any like data problem where you scrap the web, or I mean that's something commonly happens when you.
I think the more difficult thing is how to identify different kinds of products, because you cannot. I have a hard time to using like data mining to see different kinds of products. So I have to coordinate with the designer to see what's maternity legging, what's Ganssle, and what's the difference between different kinds of products, and how to interpret it in the data.
I think we still have time to take a few more questions. And anyone? Robin?
Actually, I have another question from the poll. So it's a follow-up question for like open source project. So you mentioned that you started to want to be a software engineer. You start with open source project, and here maybe there's some students they want to be a software engineer, but more focused on data. Like, is still open source project still a very good starting point, or you think it's more important to go and boot camp to learn some stuff and then to go ahead to fulfill your dream?
Well, I mean, I don't know if I'm a model example of like how to become a software engineer, because I went and got a PhD in physical chemistry, which is nothing. Like now I price bombs with software, so it's like, I think if you're fresh out of college and you're like, I want to go be a software engineer, I don't know that open source is the best way to do it. It's a way, and I think I might be temperamentally suited to it because it's a lot of arguing on the internet about things. So a lot of people don't like doing that, and also, there's also a certain amount of, there's some responsibility with any of the benefits like being paid. So, again, if you're the kind of person who likes editing Wikipedia or things like that, then maybe open source is like worth doing. There is also part of that, like arguing on the internet, is that you get really good feedback on your code, and open source, probably because it's so scattered and you can't just have everyone get into a room with a meeting and one person makes a decision, tends to have, in my experience, better process than like continuous integration, all that kind of stuff. Just because you rely so heavily on it because you can't rely on manpower. But if you're looking for, like, if you're just trying to get into data, it may be that you're not doing things like I did with, like, contributing to libraries. It might be that you just come up with a cool project and then do a blog post about it, right? Or you make a Jupyter notebook that's like something interesting and then you just share it. That's a kind of open source, I guess.
Is there any chance we can have the
What's
slides?
up?
Oh,
Is there any chance we can have the slides too?
Yeah.
No, I mean to share the slides.
Oh, I think your slides on GitHub, right?
yeah, they're my slides. There's a Jupyter notebook that generates all those slides, and it's in the repo. So if you go, can you pull up the my slide? It's on every one of my slides. Yeah, if you go to this Ganssle.io and then you click on Talks, it's already on there. There's like an entry for the Taiwanese Data Professionals. You click on repo or slides, and there's all the slides. Plus, in the repo, there's a bunch of hidden slides, explanations about stuff.
Yes, thanks to all speakers. Feel free to talk to the speaker and talk to one of our organizers and tell us like how you feel about the event and how we can make it better. And also do the event survey so that we can make some statistics. And how many surveys we have?
Oh yeah.
Yeah, okay, let's check.
Great. So we stop at 10.
Okay. Yeah, to do the event survey so that in the future we will have more different kind of event coming up, and so we need our opinion to make it better.
And just before everyone leaves and like talk to more people, just raise your hand because we want you to talk to different kind of people during the networking session. So if you have been to New York for more than 3 years, raise your hand. So over 3 years. Over 3 years. Okay, so if you are not raising your hand, talk to the people who raise their hand. Make sense? Alright, cool. Alright.
And also we are looking for speakers, so if you have a amazing project that you want to share with people, to just come and speak to Speaker Robin and he will pick up.
Alright. Yeah, we can have the space, so now just like networking, we'll have the space about 8:30, so yeah.
There we're gonna go.